Hello, everyone. Welcome to the 2024 K-State Garden Hour webinar series. We are so glad you're here. This webinar series started in 2020 and has been a collaboration of the entire K-State Horticulture Extension team. Since the start of the program, we have reached over 62,000 gardeners just like you. We are pleased to continue offering the K-State Garden Hour series for free. If you have enjoyed these educational webinars, please consider making a tax-deductible donation to support this program. The link to donate can be found in the chat or on our K-State Garden Hour website. This webinar is hosted by Kansas State Research and Extension. My name is Anthony Reardon. I am the Horticulture Small Farms Extension Agent for Johnson County. Everyone involved in the development of this series is an extension professional for K-State. Most of us have a background in horticultural education or a related discipline, but most of all, we each have a love for educating and sharing important gardening topics. Before we get started, we do have a couple of housekeeping notes to go over. Please use the Q&A feature for questions related to the presentation. This is where we will look for questions at the end of the webinar during the Q&A session. You should see a button along the bottom tab that says Q&A. Just click on that link and you will be able to enter your question there. Today's webinar will be recorded and we will post it to our K-State Garden Hour website. We typically upload additional resources related to each topic as well. If we share links through the chat, we will also link them on the website. Our website is also where you will have access to previous topics and upcoming topics in the 2024 series. Our moderators today are Annie Baker and Laura Phillips, and they will be sharing information through the chat during the presentation. They will also help us facilitate the Q&A portion of the webinar. Today's topic is understanding water sources for your garden. I'm pleased to introduce our speaker today, Jay Harris with the Cottonwood District. Please give us a few moments while we transition and share the presentation slides.
Hello, everyone. Like Anthony said, my name is Jay Harris. I'm with Cottonwood Extension District, which is Ellis and Barton County, so central Kansas. So let's get started. So today we're going to be talking about different water sources for your garden. And I think the first thing to talk about is, why is water important? So first thing, water carries nutrients from the soil to the plant cells. This keeps them hydrated, keeps them stronger and healthier. And water is an essential component in photosynthesis and plant metabolism, which includes cell division, which is what makes our plants grow. And it also cools the surface of land plants through transpiration. And especially in western Kansas, central Kansas, water is a primary yield determining factor when we look at crop production, whether it be in our garden or even in our lawns. So we want to talk about getting a suitable source of water. And we have to remember that not all water is suitable for irrigation. There are two major factors that we look at when we look at whether our water is going to be suitable or not. First of this would be salinity, and the second thing is sodium. So salinity usually shows up on a water test as conductivity. When you look at a water test, it's going to say conductivity on it. It can be measured in micromoles or millimos, and it's important to know which one is reported on your soil test, and I'll show you why here in a second. And then we also look at total dissolved solids. So this is a measure of the total content of all inorganic and organic substances present in a liquid. It's measured in parts per million. It's highly related to the quality and the purity of your water. And this is what can affect hardness and pH. So when we talk about salinity, we have 5 different classes of our water. And so here you can see the electrical conductivity. This is reported in micromos. So this is where it's very important to know if it's micro or millimos that's being reported. And then we have total dissolved solids. So we have 5 different classes: excellent, good, permissible, doubtful, and unsuitable. You can see the different rankings there of where they would fall on that table. So if you know what your water tests look like, you could determine which class your water falls in. So class 1 is excellent. You can use it for almost all crops. Class 2 is good. Again, use it on almost all crops. You might start seeing a little sensitivity here to plants that are sensitive to salinity. Class 3 is permissible if you have some leaching. So whether you're getting rainfall and leaching some of that salt out of the soil would be good, or if you're watering with some other source intermittently. Class 4 is doubtful. In this case, you do need to have good drainage in your soils, but sensitive plants could still have difficulty obtaining a good stand. Class 5 is unsuitable, very high salinity, cannot be used for irrigation on a regular basis. You can use it occasionally, but the rest of the time you would have to find some other source to water your garden or your lawn. We probably recognize this little science experiment from high school chemistry, whatever it might be, where you take a salt solution, you put it on a stand with a Bunsen burner, you evaporate the water out of it, and what you have left is salt crystals. And that's what happens with the water that's high in salinity, is as our water evaporates or taken up by the plant, we keep continuing to get higher amounts of salt in there. So that's why we have to be careful using those water sample or the water sources that are high in salinity. So let's talk about sodium. When we look at sodium, one thing we concern ourselves is what we call the sodium absorption ratio. So it's a water quality parameter, and especially if we have sodium affected soils, we really want to keep an eye on this. And it's an indicator of the suitability of our water. So this is the formula to calculate that, and you're probably thinking, I'm not going to take the time to calculate this, which is good because you can go online and find an SAR calculator. On this picture here, I have the link shown on the bottom there. So what you do is you take your water analysis, you put in what you have for calcium, what you have for magnesium and sodium, and it calculates it for you. So this is an example of the well that I have at my house. The SAR calculates out to 6.6. And you see a note on there that says a water SAR below 4 will minimize soil hardening. And we do see some of this in our area, especially like with this water, it's above that 4, and we can cause some hardening of our soil and decrease the water permeability. So here is a ranking, 4 different rankings: low, medium, high, and very high, based on this SAR. So you can see that sample that I had there of mine, it was a 6.6, so it still falls in the low. But like I said, we do create some issues with that water, even though it's low. As you continue to move up that scale, when you get to a medium, if you're having that hardening of soil, you might have to put on an amendment such as gypsum and then help leach that sodium out of there. And then when you get the high and very high, a lot of times it's unsuitable for use. So very good idea to have the sodium absorption ratio calculated on your water. So different things to watch for in a water test. So like I said, the high amount of salt, the salinity. It stops the plant's capacity to uptake water and nutrients, results in poor growth of the plant, and it can actually cause salt stress, which is growth inhibition. And even if you're doing it too much, you can cause death of that plant. Excessive nitrates. If you have excessive nitrates in your water, you can cause over-fertilization. And you can also create algae growth in your water. And this algae then can affect the plant's overall health and development. But if we have excessive nitrates, can it also be beneficial? Yes, but we need to calculate the amount of nitrogen that we're getting from our water so that we can credit that towards our nitrogen applications. There's a simple formula for doing this. You take the total season irrigation, what you're expecting that you will be applying, times the amount of nitrate in your water sample, milligrams per liter, or same as parts per million, times 0.23, gives us our pounds of nitrogen per acre. So an example, if we were going to apply 12 inches of irrigation, we have a parts per million of our nitrate of 10. I use 10 because that's the maximum contamination level that's allowable in our drinking water. Times the 0.23 is 27.6 pounds of nitrogen per acre. You divide this then by 43.56 because there's 43,560 square feet in an acre, and we want to convert this per 1,000 square feet. So in this example here, we'd have 0.63 pounds of nitrogen per 1,000 square feet. Doesn't sound like much, but consider this. General vegetables require 2 pounds per 1,000 square feet, and high feeders such as tomatoes, broccoli, and beets require about 3 pounds per 1,000 square feet. So even on those high feeders, we are, putting on about a fourth of the nitrogen that we need with just our irrigation water. And if we look at what this is gonna do to a lawn, so tall fescue, we're looking at a medium quality expectation. We need 2 pounds of nitrogen per 1,000 square feet. And a lot of times we want to concentrate in this medium area, especially in our part of the state of Kansas. If we push for that high, we're going to create some other problems. So if we're only needing 2 pounds per 1,000 square feet on tall fescue, we're putting quite a bit of nitrogen on with that water sample I showed you earlier. Dr. Matthew Kirk from K-State, they tested 23 wells in Barton County as part of a NSF-funded Kansas Groundwater Geopaths program. They had one well that tested over 55 parts per million nitrate. The average on those 23 wells was 13.69. So if we are talking about a fescue lawn, applying 1 inch of water 20 times, with that high nitrate water, we're going to be putting on 5.85 pounds of nitrogen per 1,000 square feet, which is way above what is recommended. If we look at what the average was, we would still be putting on 1.45 pounds of nitrogen. So pretty well everything that we need for nitrogen will be coming through that water. And even if we look at one that's 5.3, this is the well at my house. Doing that 20 inches of water, I'm getting a little over 0.5 pound of nitrogen per 1,000 square feet just out of my irrigation water. So what else can we watch for in a water test? Large amounts of iron. So this would come from a well that's continuously in contact with underground rocks. We can get a high level of iron in our water then, and this high iron it affects our chlorophyll, which causes discolored bronzing on the foliage, can even become a reason for stunted growth. And if it's high enough, you can even get a metallic taste in your water. So if you've ever drank the water from your water source and it has a metallic taste, it's probably high in iron content. If we have a high ratio of calcium, so this would be water that's continuously in contact with calcium carbonate, limestone, Very huge problem in western Kansas. Most of our parent material is limestone, so we have a pretty high ratio of calcium in our water. And as it comes up, that calcium level comes up, it'll directly affect our plants. It makes our water alkaline, it raises the pH. And then we can also cause some negative effects on the germination of the seeds, and even later on lessen the plant growth rate. If we have a high level of magnesium, so if we have high levels of calcium and magnesium go pretty well hand in hand, that's what we call hard water. And hard water reduces the ability of a plant to absorb nutrients that we need for them to grow properly. So let's look at the different water sources that we might have available to us. We have tap water, well water, rainwater, gray water, spring water, and then water from our ponds or lakes. So these are the 6 main sources of water that I'm going to talk about today. So let's look at tap water first. So tap water is water from a municipal treatment facility. It's usually the spigot that's on the outside of our house. And the diagram there on the bottom right, you can see that's kind of how water goes through a treatment process. And this can be either a city treatment facility or even a rural water district. Now, some of the rural water districts do not treat their water to the same level that a city would, but it's still a good idea to have it tested so you know what's in it. So a lot of times in our tap water, we have chemicals that are used to treat the water so that it's safe for us to drink. A lot of times the main thing that is used is chlorine. And we can use this water and we can dissipate that chlorine out of there if we have air contact. So a lot of people, when they use tap water for watering their plants inside their house, they can let the water set out for a while and that will dissipate. But this could be burdensome for a gardener, to have their water sitting around trying to get the chlorine out of it. And then also in the recent years, water treatment facilities have switched to chloramines rather than using straight chlorine. So you ask, what is a chloramine? So this would be water that's treated with both chlorine and ammonia. And the chlorine is converted to chloramines. And sometimes we even have small amounts of plant material in our water based on where it's coming from. And then when we use chlorine, it mixes with these phenols, and then we produce chlorophenols. And this a lot of times is what makes our water taste and smell bad, is when we get these chlorophenols going in our water. This change to using chloramines was done mainly to eliminate foul taste and odor of these chlorophenols in our water. So some city treatment facilities have switched over to the use of the chloramines. Same thing, if we are using it for our plants, we can still dissipate that out of there with air contact. Also, so there's been research done that's shown this tap water, there's minimal or a temporary damage to microorganisms. And if you have good amounts of soil organic matter, this damage is going to be lessened. And what happens is the chlorine binds to soil particle surfaces or to the organic matter particles, and then therefore the plants will not take it up, or the microorganisms will not be digesting it, so it's not going to kill those microorganisms. Organisms in the top surfaces of the soil or compost can be affected after irrigation. And again, that's in the surface is the biggest area this is going to happen, because as the water moves downward, there's very little of this chlorine that remains in the water. Again, it's tied up in the soil particles and the organic matter, and keeping that from moving downward. You can also remove some of this chlorine with different chemicals. It's called dechlorination. And we use different reducing agents such as hydrogen peroxide, ascorbic acid, which is vitamin C, and different sulfites. So you might even look into using one of these reducing agents if you're concerned about the amount of chlorine in your water. So one thing to remember is that the more life that is in the soil, the more quickly the unwanted chemicals will clear up. And so when we're saying the more life, we're talking these microorganisms. So if we keep our soil rich and full of organic matter, and then it's going to help out these microorganisms and not have a problem with the water in there. So let's look at well water. So you might have a well that looks like something like this. It might be on the outside of a house, it might be down in a well pit, wherever it might be. The big thing here is to test that well annually. We have a lot of things happening to our well water, especially in Western Kansas right now. We're in a drought. And so we're having things changing quite rapidly in our well water. So you can use it to water plants if it's clean and has a suitable pH. And that pH would be from a 6.5 to an 8, so pretty close to neutral. 7 is neutral. And tested regularly, so we make sure it doesn't contain biological or chemical contaminants. And this could be something that's going to affect the growth of our plants. The biological contaminants can be caused when our rainwater goes through contaminated soil, places where we have bacteria, protozoa. We can have chemical contaminants in our water, which includes those salts, as I talked about earlier, different heavy metals, calcium, magnesium, potassium, and lead, human waste, and animal dung. So when I say human waste, if you're in a location, a rural location where you have a septic tank, you do not want your well located close to where your leach field would be. You do not want that water coming out of your leach field getting into your well water. And then with the animal dung, if you have your well close to a livestock handling facility, we can get some different contaminants there too. And both of those, the human waste and the animal dung, could also create a biological contaminant. And then if you live near an industrial area, there could be slight chances that you have chemical contamination, but that's going to be a very slight chance there. So domestic wells, generally safe for watering plants. The groundwater can contain other elements that may generate a level of toxicity. So that's what I'm talking about, is to be sure and test that water, and then keep those wells away from leach fields or livestock handling facilities as well. So what are some of the benefits of using well water? A lot of our well water has nutrients. Well, first off, some areas it's cheap and readily available. And that's most areas. Some areas like Western Kansas, we're not so lucky. Actually, in the area where I live, I had a neighbor that was using his well to water his lawn 3 and 4 times a week, putting on massive amounts of water, and he caused my well to go dry at the end of last summer. So the other thing, if you are using a well, be cognizant of what you're causing to the whole area, your neighbors that's using that well water is also. It's affordable. Once the well is drilled, if everything goes well and you don't have any damage, that well is going to last for a long time. And then the other thing that's really beneficial with that well water is it filters through the rocks. It picks up some essential nutrients, potassium, calcium, iron, magnesium, all the elements that we've talked about so far. And some plants love to quench their thirst using well water because it contains nutrients that a plant needs. Just like earlier when I showed with the nitrates that might be in there, most wells are not going to be above that contamination level. But still, we're going to be getting some nitrogen from that well water also. So rainwater is also an excellent source for watering. I know on my lawn, I can always tell when you've had a nice rain, the lawn looks better than if you water it with my well water. Though it's naturally soft, so it has fewer concentrations of magnesium and calcium because it didn't come off of the rocks. pH of rainwater is usually less than 7, so it means it's slightly acidic. And it can even be down as low as 5.0 and 5.5. So that's one thing I really feel when we get rain water on my lawn. Like I said, some of it's from that lower pH, and we have high pH soil, so it helps out the lawn a little better. So one question for you, true or false? Rainwater is the purest form of water. Does anybody have a thought on that? Just kind of think to yourself, is it the purest form of water? That is false. And the explanation behind this, according to the U.S. Geological Survey, rainwater is usually fresh and clean, but it still contains small amounts of particulates that have been blown into the air by winds. Rainwater contains tiny particles of dust and dissolved gases, such as carbon dioxide and sulfur dioxide. And the sulfur dioxide would be what we would consider acid rain. It is not possible to find completely pure water in nature. You got to remember that as well. So as rain falls, the water droplets dissolve different substances that are in the atmosphere. These are gases, airborne dust particles, and if you're close to the ocean, it could be salt from sea spray. And then also atmospheric pollution can have a major effect on the composition of rainwater. Water that reaches the earth as rain acquires other substances from processes such as leaching, weathering, dissolution. So this would be, as that water goes through our profile by leaching, it picks up other things too. And then also we can have some living organisms that enter the water as it falls. So all these different processes can affect the composition of that water. So there's 3 different types of contamination. So micro or microbiological contamination. So these would be enteric pathogens such as bacteria, viruses, and protozoa. And we say enteric pathogen, these would be things that cause gastrointestinal illnesses. And the most important indicator is E. coli. Chemical contamination would be from air pollution, runoff, leaching of chemical substances. And then in rural areas or developing countries, these activities, they're absent or on a small scale. We don't have the air pollution there. So that chance for chemical contamination would be lowered. And then we have a physical contamination. This could be inorganic, organic, or organic. And there could be sediments, sand, silt, clay, or parent material. And this is going to affect the color, the odor, or the taste of the water. So one thing with rainwater, this is a very common practice in Western Kansas and all over the state of Kansas, is rainwater harvesting. So in the summertime, 40% of our household water is used for outdoor watering. It's a pretty high percentage there. And the plants may be more vibrant and hardy when irrigated with rainwater. We talked about that a little bit. So why not try to collect that rainwater so that you can use it at a later time? So here we have a picture of a standard rain barrel. Can be made out of most any clean type of barrel that you can find. Some rain barrels are even decorative. Like the example here I have of an old whiskey barrel, very decorative, gutter as well, and with the spout coming into that barrel. So the most common method is collect rainwater as it comes off a roof. These barrels need to be equipped with screens and covers to filter out debris and also keep out insects or even small animals. You can use a new or contaminant-free 55-gallon drum. You can use these and convert them into a rain barrel. I have people ask me quite a bit or quite often if they can use these 250-gallon chemical shuttles. I would definitely advise against that because of the chemical that could be present still in that chemical shuttle. So I definitely advise against using those. Sometimes your garden supply centers will have ready-made barrels, something that you can go buy from them. And when you install these, you need to have a spigot installed near the base of that. And if you can attach it to a garden hose, that's the best thing, so that you can get that water to where you need it. But if you can't get that elevated high enough, have it high enough then that you can get a water can underneath of it, or some other way that you can fill it up and use that water where you need it. So one thing to definitely keep in mind, it's good for your plants, but it is not drinkable water. It is not something that you want to be drinking. The other thing about rainwater harvesting, check your local ordinances if it's legal to collect rainwater. There are some parts of the United States that it is illegal to collect rainwater. And there are also some places where there are certain laws in effect that you have to follow. In Kansas, collecting rainwater is legal. And this is because of the Kansas Water Appropriation Act. It protects our right to harvest rainwater to use for domestic purposes only. Some states have restrictions. You might have to have a licensed contractor install whatever you're collecting the rainwater in. And if you live in a homeowner association, there might be regulations related to the design of the barrels or how you might have to cover them up so that everybody can't see them. So be sure before you put rain barrels in, make sure that you know it's legal to do it where you're at. So the next type of water I want to talk about is gray water. So this would be any household wastewater, including water from washing machines, dishwashers, baths, and a sink. Those would be things that would be considered gray water. And you would need to use this water before it comes in contact with the sewer. So this is going to be water that you use before it comes in contact with a sewer, septic system, whatever it might be. So it uses this wastewater instead of it winding up in the septic or sewer systems. Because then that water can eventually end up in other bodies of water, and then it can pollute those water bodies. And so we're trying to curb, curb this form of pollution. It is a good source for watering your garden. It does contain phosphorus and nitrogen from biological matter, so we can, that would be a positive for this source of water. Be very careful if you're using kitchen wastewater. So if you have fats in that water from washing dishes, whatever it might be, these fats can actually damage the plants instead of nourish them. So when you use this for irrigation, make sure you don't puddle it up or pooling in the garden. Make sure it's soaking in. You do not want gray water standing on the surface. You can use it to water fruit trees, ornamental plants, and the edible plants' roots, the roots only. Do not spray this water across the top of the plants. Put this water directly on the soil. It is not safe for use on root vegetables, radishes, carrots, potatoes, or the plant's consumable parts. So that's why I'm saying do not spray this water directly on the plant. Anything that's going to be consumable, do not use it on your root crops. You can use it on the other items like I mentioned, just do not put it on the part of the plant that you're going to consume. So spring, pond, and lake water. So I'm going to lump these three together because a lot of times we think of these three types of water together. So be careful which water is beneficial, toxic, or harmful. there can be some issues arise here. So one of the cheapest options is untreated groundwater. So this would be spring water or your lake and pond water. So this is the biggest thing to remember. This is untreated groundwater. It's untreated by human means. Now, spring water is filtered through layers of rocks and soils, just like the well water would be. And that is actively going to filter out contaminants and get those mineral deposits. So of the three, spring, pond, or lake water, spring water would be the cleanest and uncontaminated or least contaminated of those three choices. It's not bad for plants, but it has to meet a few conditions before you want to use it. It needs to contain the right amount of nutrients. So again, it would be a good idea to have this water tested as well to see what's in it. Make sure it doesn't contain any harmful bacteria, and make sure it's coming from a source that is not stagnant. And unfortunately, when we use pond or lake water, it's coming from a source that has been sitting there for a while. So it could be from a stagnant source. Stagnation can invite animals and insects to drink it. And then a lot of times we know animals, when they go to drink from that water, sometimes they stand in it, and other things in the water as well. And so this can cause the bacteria to build up and continue to grow in that water. If it is stagnant, not purified, this can cause damage to our plants for many different reasons. It could have deadly pathogens, harmful bacteria in it, and this can damage the plant. And then if it's eventually taken up into the plant, it could affect your health as well. So be very, very careful with any water that is stagnant. And that even kind of goes back to rainwater harvesting. When you're harvesting rainwater, don't let it set in those rain barrels for a long time before you utilize it, because we can also cause some of these problems with rainwater harvesting. It can be too acidic or too alkaline. Again, a good reason to have it tested. And then this contaminated water leads to diseases for both the plants and for us when we go to consume that fruit or vegetable. So a few takeaways from my presentation today, some things that I would really like for you to remember. Most sources of water are good for your lawn or garden. We're trying to do whatever we can to keep them healthy and producing like we want them to. But the big thing is to test your water source. Make sure you know what you are putting on your garden, especially if you're going to be consuming produce from that area. Next thing is test your water source. I want to stress that. Really make sure you know what you're putting onto your lawn or garden. And lastly, test your water source. All of these are good sources to use, but just make sure it's being tested so we know what you're using. And with that, that is the end of my presentation, and I am ready to take questions.
Thanks for that great presentation, Jay. We've got a couple questions in the chat for you. The first one is, I'm curious on thoughts around reusing laundry water to water plants, assuming that no bleach or peroxide is used in washing.
That is correct. So if you are using water from laundry, make sure that you are not using chlorine, because then we're going to create the same issues or even more severe issues than tap water that's been treated with chlorine. And most of our laundry soaps anymore, they do contain nutrients, especially phosphorus, that would be beneficial to our plants.
Awesome. The next question is, why is rainwater collecting restricted or illegal in some places?
I think Kansas has done a great job of making it legal for us. I don't know why somebody would want to make it illegal. But just with the research that I've done, and I can't tell you off the top of my head which states it is, but you can search it really easy on the internet. For just example, if you live in Missouri, just do a search, is rainwater harvesting in Missouri legal? And you'll find out real quick. Yeah.
Awesome, thank you. The next one is I use large 250-gallon containers that held food grade liquids. Your thoughts on this?
Those are very acceptable. In our district here, we actually build rain barrels with the help of one of our regional specialists. And they are using 55-gallon drums that were used to transport material that goes into making Pepsi. It comes from our Pepsi bottling company. And anything that's food grade, perfectly fine to use. Definitely the thing I want to, advise against again is the chemical shuttles or totes. They're very nice. They have a metal cage on them, 250 gallons. That would be nice to have that. Actually, here at our office, we have a 500-gallon tank that was purchased from an ag dealership. It was clean, never used for anything else. Our building is quite large, and it only takes about 10 hundredths of rain to fill up that 500 gallons. So it's a pretty good indication of how much rainwater you can collect.
Awesome. The next question is, how often should a person test their well water? Is it true we need to shock the system with chlorine at some intervals? And then they added, we've only done it once 25 years ago. We're in the Flint Hills and have delicious tasting water.
So I do recommend testing every year, especially if you're using it for drinking water. If you're mainly using it for garden or lawns, probably every 5 years. You only need to shock chlorinate if you have coliform bacteria present. So when you are testing your water, send it to a lab that can also test for coliform bacteria. There's guidelines to doing that. You have to have it to the lab within 48 hours of when you took the sample. So don't send it in on a Thursday or Friday, collect on a Monday or a Tuesday and get it sent in right away. And then if you have come back with a coliform bacteria, most of the labs that we use, they will give you the recommendations on how to shock chlorinate that well.
Awesome. And we got a couple questions that came through on where to go for water testing. And I put in the chat for those just K-State's links, but you might want to, maybe you would want to speak a little bit about the testing that K-State offers or does not offer and where to find those resources.
So for Western Kansas, we use Servitec Labs. We have their testing kits in our office. Most of any of your other agricultural testing labs will do water samples. Yes, just stop by your and Annie put in the chat there about the water testing for different things as well. A lot of times for us here in Western Kansas, it's hard to get those water samples there. So just check with labs close by, check with your local extension office. If they do offer that, they will have the collection bottles for you to use for you to send in.
Awesome, thank you. Our next question is, how long can you keep water in a rain barrel? I want one, but most of my plants only need 1 inch of water a week, and I worry about it going bad.
With that, kind of maybe gear your rain barrel size to what your goal is. Maybe you only need something that's 30 gallons versus, using the 55-gallon drums like we use. I would definitely say that you would want it to be out of there within a month, because that's when things are going to start happening. And it's also very important, the color of the rain barrel. If you have something that's black, that's going to absorb heat, could create more, algae growth in there than if you have something that's a lighter colored reflecting that heat. And so also a very good job of putting screens on it so that you're not getting debris in there, because that debris will also affect how long you can keep that rainwater. The cleaner you can keep it going in, the longer you can keep it before you use it.
Awesome. The next one is, what are your thoughts on using pellet softened water to water plants?
That's a very good question. Actually, my wife and I argue about this all the time. If a water softener is set correctly and is set to the hardness or the electrical conductivity of the water that's going in, then you are not going to have salt in the water that's coming out. Okay. So most good water softeners are going to only use the salt to clean the resin off that's inside of the water softener. The water softener is going to remove the calcium and magnesium. It's then going to be flushed to get the salt out of there. And if your water softener is working correctly, there is no salt in the water that's coming out of it. Now, if you're drinking that water and you taste salt, there is probably something wrong with your water softener. Yes.
Thank you. The next one is, my well is 50 feet from my lagoon. How close is too close? And this one I did give them a publication with some recommended distances, but if you wanted to kind of talk about that a bit more.
That is an excellent publication, and I do not remember those distances off the top of my head. So 50 foot might be getting a little close, and it depends on also, when we talk about groundwater, we don't realize that it is flowing. Okay, a lot of times it's not just sitting there. So there are all sorts of USGS tables that you can bring up, or maps that show the flow of groundwater. And maybe that would also help you realize or recognize what direction the groundwater in your area flows, and whether the groundwater is flowing, from your lagoon towards the well or vice versa. So that would help you out to determine distance as well.
Great, thank you. And then our next one is, organic material in the soil helps plants when using water from municipal sources. What level of organic material is recommended?
Most of the time we want to have an organic matter of at least 4% or higher. Now, sometimes when we get too high, we can create some problems, but I think if we're above that minimum of 4%, it's definitely going to help reduce that chlorine or chloramines from tap water. So 4% or greater.
Okay. And then I have got a follow-up question. The person who asked about the 250-gallon food grade containers, she followed up and said, I asked because you mentioned not to use the 250-gallon metal cage tanks.
Right. And it's not, biggest thing is what was in it. So if it was food grade before, you're going to be fine. So anything that it's had in it, like I said, we use the ones from Pepsi Bottling Company. It was material in there that's going to be designed for human consumption anyway. So anything that's food grade is fine.
And then the last question that we currently have is a follow-up from a previous question. Would it be bad to use rainwater from a roof to water fruit trees and edible plants, or could any contaminants possibly transfer to food?
Most of what's coming off of our roofs, we're going to be fine. The only issue that I've ever seen would be rainwater that was harvested during a hailstorm that loosened a lot of the material from the shingles. That would be an example. If you have that happen, that would probably water that you would not use. And that would be the only time that I could see. I do know a lot of people that with their rain barrels, they do not have them connected in the spring, especially if they haven't cleaned out gutters, things like that from over winter. If the gutters have collected a lot of different residue in it from over the winter, they'll disconnect their rain barrels until they've had a couple rains to clean the gutters out before then they start harvesting the rainwater.
Great. Thank you. We had another one come in that says, do contaminants come off roofs when collecting rainwater? Is there a variation by roof type? And is there a way to filter water to keep contaminants out?
So I think, like I mentioned with the shingles, might be one time that you wouldn't want to collect after a hailstorm or something. Off a metal roof would never be a problem. Not as much necessarily when we talk about filtering the water going in, but I mentioned the 500-gallon tank we have at our office. When we use that water, we filter it going out. So if you're pumping it, we use an electric pump. We have a filter system on that, which is only going to get out of or get the solid particles. It's not going to do any chemical contamination, but there shouldn't be any anyway. But yes, put a filter as you're coming out of the rain barrel can help get some of those sediments out of there too.
Awesome. And then we had another one come in that says, how would you recommend capturing gray water from household use?
That's a little more difficult question. Some places I've seen will actually install like an old cistern. Cisterns were used a lot in years past. Some type of a system where you're going to have to break out the sewer lines in your house. Things that come from your sinks, washing machines would go into a separate line than what's coming from your toilets that's going into the sewer system. So it would mean some change in the plumbing in your house, plus then putting in more than likely something underground outside to collect that gray water, because it's all gravity flow. So it's going to have to be lower than any drain in your house.
Awesome. Well, that was the last of the questions that we had for you. Thank you so much for this wonderful presentation and for all of the Q&As.
Thank you. Great questions, everyone.
Okay, thank you to Jay and to Laura and to Annie, our other moderator, who's busy typing away in the chat. We typically have more questions than we have time for, but we will be sure to link several articles related to this session on our website. We hope these resources will help to answer your questions, but if you need additional information, contact your local K-State Extension office. Once again, thank you for joining K-State Garden Hour series hosted by K-State Research and Extension. We are so glad you could be here today to learn about understanding water sources for your garden. We are excited to continue offering this webinar series throughout the year. You can visit the K-State Garden Hour website to view our recorded Garden Hour archive, or to make a tax-deductible donation to support the continuation of this webinar series. This session was recorded and will be posted on the website by tomorrow afternoon. After this webinar ends today, you will receive a prompt to take an evaluation survey. Please fill this out. We would greatly appreciate your feedback. If you have any other questions, please don't hesitate to reach out at gardenhour@ksu.edu. Thank you again. We hope you continue to tune in on the first Wednesday of each month. Have a great week.